So we talked about, yesterday we talked about complementary versus supplementary. And I would have that on my study sheet. I would have them there next to trig, just so you know, right? Have the little visual there to help you out, which one is which. And if you recognize a right angle at some point and a line that cuts it, you're like, oh, if I have one, I have the other. Same with supplementary, right? If you see some sort of straight line, and it could be going this way as well, right? It doesn't matter. If you can picture that and see one that's cutting it, watch out. It's probably a supplementary angle scenario. So let's go to 34, and we'll go over it. Ready? So they have done this where they ask for the angle using this notation, the three-letter notation. So that's the angle and EFD. So you just start in E, go to F, and then go to D, and just keep traveling that a couple of times so it stands out to you. Oh, okay, it's these two sides right here that I need to connect. So it's that angle right here in this corner, F. F is in the middle, that's another giveaway, right? It will be where F is. Is it this one or is it the other one? Like, which is it? Because there are multiple angles, okay? So let's figure that one out. Angle EFD, and if you don't like three-letter notation, use a letter that hasn't been used yet. So if you, for example, want to use X, right? And then just say, I'm going to put an X there. So from now on, I'm going to call it X. That's fine. Okay. So do you see the straight line? I hope so. You should be able to. Oh, there's one next to that angle I want. You should highlight it. Be like, oh, there's a hat there, right there. There's a supplementary angle. Right. This means we've got 180. At hand here. So if we have the 70 here, we can easily find that one. Okay. So all you do is to show that is 180 minus 70, and that's 110 degrees. And you're done. You've answered. You now know that EFD measures 110. They also ask us for angle D, which is up here. Okay. And let's do that. Let's answer that here. I know there's a lag. I can't fix that. I'm going to have to get a new computer or something. 180 minus the 40. So now we're dealing with a triangle, right, where we have two angles. We have the 110, this one, and we have the 40. So we subtract those two angles from 180 to get D, because guess what? There's nothing next to D here. You can't do what we just did down here. Okay, up there you can't. So that would be 30. So this is 30 right there. So 2 marks usually. You usually get 1 for each when it's like that. So now you have more information on that triangle. Calculate the lengths of sides ED. Let's use a different color for that one. Where is ED? ED is this one here. You just travel from E to D, right? Got it? Put a letter there if you want. You want to call it Y. You've already used up X. You can't use that letter again. So what can we do? What law are we going to use here? Where's my pen when I need it? Right here. Maybe let's put the 30 in here. And I was thinking last night, I was like, you know what? How can I help you out here? Because sometimes you don't see the sign law. Where's the pair? What are you even talking about pair? Right? Try, for example, the 30 kind of goes with that one. Try something like this. I will use the sign law here to help me out. So that's the one I know. This angle is 110. Sine of 110 goes across the side that is y, correct? And then last but not least, you have sine of 40. Let's see. This angle is across this side right here. You can call that z if you want. Okay, that's what the sine law says, that all those pairs are equal to each other. Okay, so when it's asking for ED, it's this one here. You're going to want to use that, right? The pair you know, and the 110 allows you to find angle side y. Okay, so we're going to go sine of 30 over 1539 is equal to sine of 110 degrees over ED. I'm going to actually, I hope you're okay with me. I'm just going to stick with that, ED, so you can see it in your notes. There's nothing wrong with that. And then you cross multiply and divide. So we're solving for a side here. So it's 1539 times sine of 110. And I don't have the key ready to go, so I'm just going to go and do this with you. Could you have used cosine law here? The answer is no. Because think about it, cosine law needs side angle side, so that's two sides, right? You only have one side. And then there's side, side, side is the other one. Definitely not, right? So cosine is out of the question. Rule it out. It has to be sine law. Maybe that's better for you than finding the pair. Maybe you don't see the pair right off the bat, right? So there we go. That's ED. And I'll use the same pair again. Sine of 30 over 1539. Now I'm going to use sine of 40 because that angle is across side DF. Is this okay to do this? Yes, it is, right? You might not like it, but you can introduce variables of your liking if you'd like. The DF, if you do all that, let me see, maybe I just need to flip a few pages and find it. 1978.50. And we are in kilometers. So there you have it. This was just an aside, to be honest. This is just emphasizing sine law. That's what we're using. We're using this property right here to solve for missing sides. And we could also use it for angles. But I will say this, if there's a supplementary or a complementary scenario, solving angles is this is how we do it. We use the property of supplementary or complementary to figure out that angle we need to get started. So that's usually what it is. Okay, I told you that sine law, cosine law works on right triangles, right? It works with right triangles as well. So if you ever have a 90 anywhere, you may use sine law, cosine law, just like before. It works just as well. The only, I'm going to tell you already, maybe you should grab the calculator so you don't forget, sine of 90 is 1. So some students get thrown off by that. They type it in, they get 1. They're like, what? I must be doing something wrong. No, that it's supposed to be 1. Okay, so if you type that in and nothing happens, because some students go cross multiply, they're like 2.5 times sine of 90. What? It's 2.5? Yeah, because sine of 90 is 1. So that's the only thing that you may encounter that might throw you off. But other than that, if you have a 90, you go for it. Use sine law or cosine law. Okay, we're going to park this, but kind of get ready to come back to this part. We're going to do a short AC, and then we'll continue our journey.